Everyone, in this very video we are going to be looking at exact differential equation, to be particular exact first order differential equation. Now please, before we continue, you can click the subscribe button below to get notification of all our videos. Do well to like, share, comment. I like to know your views. Okay, so by definition, the expression mxy dx nxy dy is an exact equation. Okay, it is the total differential du. That is, there exists a u xy such that partial derivative of u over partial derivative of m and partial derivative of u all over partial derivative of y is equal to n. Okay, if the expression this is exact, then the differential equation mxy dx nxy dy equal to 0 is called the exact equation. Okay, so your m must be a function of xy, your n must be a function of xy, and your m, which is equal to the partial derivative of u all over the partial derivative of x, and your n is equal to the partial derivative of u all over the partial derivative of y. Now, the idea is that if such equation is an exact equation, then the m dy, partial derivative of m with respect to y, must be equal to partial derivative of n with respect to x. Okay, so that leads us to the solution of an exact equation. We see the first question here. It says to show that 2xy minus 3x squared dx plus open bracket x squared plus 2y close bracket dy equal to 0. To show that it is exact and to solve it. Okay, remember our condition for being exact. Okay, we call this to be m, so our m is 2xy minus 3x squared. We call this to be n, which is x squared plus 2y. So we find the partial derivative of m with respect to y. When you differentiate m with respect to y here, this will be 2x and this will be 0 because it has no y, so derivative of a constant is 0. So that's why we have this. The same, the n over dx is 2y. That's because we are differentiating n with respect to x. Differentiating n with respect to x. So if we differentiate x squared here, it's going to give us 2x, not 2y. 2x. Differentiate 2y with respect to x here, it is 0. Okay, so you can see that your partial derivative of m with respect to y is equal to partial derivative of n with respect to x, which is 2x. Okay, so now we see the solution to that question. Let uy be a function such that the u equal to mxy dx plus nxy dy. But before we continue with the solution, we are sure from here that the equation is exact because the partial derivative of m with respect to y is equal to the partial derivative of n with respect to x. Okay, it says let ui be a function such that the u is equal to m into xy, m function of xy dy, n dy, m dx plus n dy. Okay, then du dx is equal to m, du dy is equal to n, and that's because this particular derivative here can be written as du over dx x, then plus du over dy, partial derivative of u over partial derivative of y dy. Okay, so we continue from there. You can pick any to start with. So we choose to start with this du dx equal to 2xy minus 3x squared. Okay, then if we make u subject of formula by dx cross multiplying here, okay, we get 2xy minus 3x squared dx. Then it means that u now is integral of 2xy minus 3x squared dx. But remember, we are integrating with respect to x, so just x. So if you integrate 2xy with respect to x, you're going to get 2x squared y all over 2. Integrating x is x squared over 2. Remember, it's a partial integration, okay? So that will give us x squared y. And the same way, integrating 3x squared with respect to x will be 3x cubed over cube, and that will give us s cubed. That's why we got this. Then of course, whenever you integrate a function of x, y with respect to x, it means that there will be a constant, integration constant, which must be a function of y. That's the same way if you integrate with respect to y, then there must be a constant which is a function of x. So that's the reason we have that. Okay, so we have this u equal to x squared y minus s cubed plus ty, which is a function of y. So here we can now differentiate u with respect to y. Okay, if we do that here, differentiate this with respect to y, you're going to get x squared. You're interested in just y. Actually, you get x squared times 1. When you differentiate y, is 1, so that gives us x squared. Then minus s cubed. When you differentiate this now, because we are differentiating with respect to y, x is a constant, so and the derivative of a constant is 0, so we don't have that. Then differentiate this function with respect to y. That's what we have as t prime y, because we don't know exactly the definition for ty. Now, but remember, we started by saying that du dy is equal to n. Okay, and n originally from the question is x squared plus 2y. Okay, so if we compare both of the equation, here is what I mean. Remember, from derivative, from differentiation, we got this du dy is s squared plus t, and already from the question we know that du dy is s squared plus 2y. So it will be proper to equate that x squared plus t prime y is equal to x squared plus 2y. Okay, so s squared on this side cancels s squared on this side, so we are going to get t prime y is equal to 2y. Okay, so that means t as a function of y is going to be the integral of 2y. An integral of 2y will be 2y squared over 2, which will give us y squared. Okay, so that means that our ty is y squared plus a constant c. Okay, so that's to say, remember, this is the solution of our exact equation, that u is equal to s squared y minus s cubed plus ty, but now ty is y squared then plus c. So that is the answer to that very exact equation. So we are going to look at another question here. We are asked to show that the equation is exact and also to solve the question. So we see that if we call this a m and we call this a n, okay, so our m is y squared minus 2xy plus 6x. Then if you derivative of m with respect to y, is 2y. If you differentiate this with respect to y is 2y. Okay, then differentiate minus 2x with respect to y is minus 2x. Remember, you're differentiating with respect to y, so your x there is a constant, so we get 2y minus 2x. Then you differentiate n with respect to x, so n is this value here, which is minus x squared plus 2xy minus 2. And that's coming from this. Because of this negative sign here, it affects all the signs in the bracket, so we get minus 2x plus 2y, 2xy minus 2. Now when we differentiate that with respect to x, okay, so differentiate minus x squared, we'll get minus 2x. Okay, we'll differentiate 2xy with respect to x, you get 2y. This is a constant, so derivative of a constant is 0. So you see that this and these are equal. You can see that partial derivative of m with respect to y is equal to partial derivative of n with respect to x. Okay, so that means the equation is exact. Now we can go on to solve this. We have that the m equal to du dx. Remember, the exact equation actually can be written as du equal to the partial derivative of u over partial derivative of x dx, then plus partial derivative of u over partial derivative of y dy. That's according to chain rule. Okay, so we can say here clearly that your m is du dx, and du dx equal to this, okay, which is y squared minus 2xy plus 6. Now first we can cross multiply the dx and make the u subject of formula, u subject of formula, and we get this. So making use of the formula is to integrate y squared minus 2xy plus 6x dx. When you're integrating with respect to x, your y squared here will become y squared x. That's because integrating with respect to x, y squared is a constant. So integrating y squared dx is just to introduce x. Then minus integrating 2xy with respect to x will be 2x squared y all over 2. And this can cancel out. Then integrating 6x with respect to x is going to give us 6x squared over 2. So that gives us 3x squared, okay? And and plus the integration constant, which must be a function of y. Now remember, we said earlier that when you integrate a particular function of xy with respect to x, it means the integral is going to have an integration constant, which is a function of y. In the same way, if you're integrating with a function with respect to y, we are going to get an integrating constant, which is a function of x. Okay, so but at this point now we can find the derivative of u with respect to y. Remember, we started with x. Actually you can start with du dx. You can also start with du dy, which is n, and you still arrive at the same answer. So the partial derivative of u with respect to y, now differentiating this with respect to y, your y squared x now will give us 2yx. Okay, differentiating with respect to y, your x squared y will give us x squared. When you differentiate x squared y with respect to y, you are going to get x squared times 1, because you're interested in just differentiating y, which is x squared. Then differentiate 3x squared. Differentiate 3x squared with respect to y is 0, because it's a constant. So derivative of a constant is 0. Now differentiate your ty is t prime y. Okay, we understand that. Now that leads us to this. So du dy, partial derivative of u with respect to y, is 2yx minus x squared plus t prime y, which is equal to n. Originally from the question, our n is this. So we can equate both together. That means that 2yx minus x squared plus t prime y is equal to minus x squared plus 2yx minus 2. So you can see that this on the left hand side cancels this, and this also cancels this. Okay, and we are going to get that t prime y is equal to 2. So from this you see that we can find our ty, which is equal to integral of 2, so which is 2y plus c. Okay, not just 2y, minus 2y, sorry, plus c, and that is how we got this. So substituting this now to our original function uxy is y squared x minus x squared y plus 3x squared minus 2y, which is your t prime y, then plus c, which is the solution to that very equation. Okay, so at this point I would like you to wait for more examples on the exact differential equation. Don't forget to click the subscribe button. Thank you very much. Have a nice day.